squeaking you can hear in the robot is actually one of the motors. As I say, they're kind of unpowered, so it's kind of burning. I thought about swapping all of the actual motors out, but I can't find anything that fits the same mounting with the same size shaft to take the worm getters on there. But I'll think about that, and if I can find anything, I'll probably revisit the Concorde.
Wake up. RF370 motor. Press return. Ooh. I'm buying some of these. Stop listening. Wake up. Press return. RF370 precious metal long 3 to 12 volts 8400 RPM motor. I bought 10 of them. So, you know, it's just something that is so obvious. I needed $275 each, so I spent 27 bucks. Free shipping from China. And yeah, I need a ton of motors for my CNC machine, for my robot. I have some. I have a decent number. I've got a lot of small motors which I can use for the fingers, and really small motors which I can use for the robot's facial expressions. Um, I I was planning to buy a bunch of cordless drill motors, 18 volt motors for the biceps, like the really powerful stuff. But what about for in between? What about, you know, rotation of the forearms and and maybe motors to supplement the bicep motors and all the other muscles, chest and all this stuff. So yeah, we're going to need a lot more cordless drill motors, but this is more of a mid-size motor that's a lot cheaper, and we can use a lot of them, and definitely need it for all my various machines I'm building. So yeah, I think it's a nice small motor that can do a lot, and we can group them together, and it's so cheap. Wow, just an excellent bargain. So I had to jump on that, and I felt confident making this purchase because I'm watching James Breton, and this is what he found, and he's a researcher. You know, you don't build robots without doing a lot of research. You don't just pop out one day and say, hey, I'm going to build a robot. You have to learn a lot to be able to do that. So I'm sure he did a lot of homework and picked a motor that's well respected for robotics, and is highly recommended. So you can kind of use that authority of somebody you trust, somebody that does nice work. On the software level, I'm not that impressed. On the hardware level, he's using 3D printing. Again, not that impressed. Although I think he is demonstrating 3D printing can be fairly strong, but also I'm not impressed with the lack of functional use that his robots get. But the robots themselves, I see a lot of potential there. He needs a lot more on the software end. He needs to design things to be more aesthetic and have a practical function, stuff like that. But I respect a lot that he's able to successfully make these robots. So that has to say something. So I give him a lot of credit for that, for sure. I'm just, I wouldn't be satisfied stopping where he does, or choosing such simple designs like he does. I want something far more epic. But you know what? I have a feeling he is working up to something more epic. It seems to me that he's building progressively more advanced robots, starting with something simpler. I'm just jumping straight to the hardcore. He might not have the self-confidence to pull something like that off, or the patience. So that explains it. Most people even say to me, what makes you think you could build Adam when you haven't built something simpler? Like, most people think the way he does, that you have to start off small and work your way up little by little. But that's not how I operate at all. Okay, so am I a little guilty watching robot videos all day? Sure, a little bit, but at the end of the day, we got a DIY roboticist showing us everything, and I think there's a lot of value in that. You can learn from his mistakes. You can gain some insights. Um, of course, I considered using ABS plastic to make my robot's bones. I didn't trust it. After seeing these videos, I think there's a pretty good chance that ABS plastic 3D printed bones would actually work, especially for like finger bones and stuff that's not going to generate near the force as like a shin bone or something like that. So I would actually consider it for certain bones. Um, he taught me that nylon as a 3D printed material is ideal for creating bushings. I didn't know that. I mean, that kind of sounds familiar, but he kind of pointed it out black and white. Nylon is the material of choice for bushings. And that's an important thing to remember. Also, just being aware of bushings as an option for anything that's not really high speed. Bushings are okay. You don't have to use bearings. That's good to know. It's good to be reminded of just bushings as a thing. It's good to compare my designs to his and see why mine's better, and consider whether his might be better in some circumstances. So far I haven't seen anything where his designs are better. I'm being completely honest. My designs are superior, but it's nice to see somebody else's designs just to help me further appreciate why my designs are superior and really think about it and compare it to other designs. See if it holds up as superior after comparing it. He showed me some cool stuff about how you can generate gears in software. It's very interesting. I might need to know that for some automotive applications. He demonstrated to me a really nice quality motor, which is the RF370 motor. I didn't know that that's a go-to DC motor. There's so many millions of different types of motors out there. How do I really know what to buy? And that kind of solidified that for me. And as a matter of fact, I'm pretty sure I've seen other YouTubers that use the RF370 motor. And I was close to buying it before, but after seeing this, I was like, yeah, I gotta get them. So I bought 10 of them, and I'm sure I'll be able to use them in a lot of projects, and those might be my go-to motor going forward. What I've been doing is just buying actual servos and taking all the gears off. But buying this motor, I think, is a lot easier than going that route. And it has the extended shaft, which is nice. So I don't have to make the shaft myself. And I can put my pulleys on that extended shaft, so it's really ideal for me. So yeah, I'm really excited about that purchase, which would have never happened had I not watched this. Or it would have maybe happened eventually when I started buying more motors, but no, I'm not hoarding. I'm gathering all the supplies I'll need for the projects that I'm currently working on, and I'm little by little adding more and more supplies to my collection. For example, just today I received a couple new tools, which I ordered online. I bought this wire stripper, which is for like really fine gauge jumper wires. So I don't have to use nail cutters anymore. It's very much adjustable. So that's going to be amazing. And I also just received in the mail today this wire crimper. And using this, you can add wire terminals to jumper wires. So that will be really nice too. So yeah, I'm getting it all. I'm getting all the stuff I need to do a better job and a faster job with electronics, and be able to complete jobs that I've started. Little by little, I'm gathering everything, and that's good because it also diversifies or diverts. It spreads out the buying. People always ask, how can you afford to build a humanoid robot? How can you afford that? Well, it's hundreds or thousands of small purchases over many, many years. They don't hurt so bad when they're spread out. I just spent $27 today. I spent maybe $50 over the past 5 days before that, so I've spent maybe $80 or $90 on the robot this week. But it's spread out over many years, then I don't really feel the impact of that.
Droid and upgrade them all. So for the new droid, I'm going to be using much bigger motors, which are likely to take, well, they're quite a bit bigger, as you can see. They're maybe not 8 times as powerful, although these actually, well, I don't know if they are or not, because I haven't measured them, but basically they're much more industrial motors. They look better, and obviously drills are designed to take much more load and last for a lot longer, so we've got a planetary gearbox as well, instead of one driven by worm gears and stir gears, and obviously the chuck and everything. So whether we keep that, I don't know. There are brushless motors available to replace these. This is a 550 size motor. We can get a brushless equivalent to get much more power density if we have to. Obviously that has an impact on what controller we use, but there are lots of options for these. I also have a cunning plan to run these in pairs, so most of the force is going to be conveyed by 2 motors at once. So instead of having perpendicular axis, I'm going to have something that I'm calling a triangular axis, and we'll talk more about that in a moment. We're going to be keeping the parallelogram leg design because it works pretty well and it makes things a lot more simplistic.
Crap. Alright guys, I'm going to buy some 550 motors too. I didn't know that that's the 2 big sizes. So you got RF370 and RF550. Stop listening. I've already got a $50 wire stripper that has the teeth and grip. And that does a very poor job on jumper cables. This was specifically recommended by somebody that's been working with small scale microcontroller level electronics for, I think he said like 25 years, and the perfect wire stripper for jumper cables. We're talking cables that are finely stranded, very tiny cables. The big wires, like the Stripmaster, is made for industrial and residential type wire stripping, not for the tiny cables. We're talking 28 gauge stuff. For that, you want the kind I just showed you. It's finely adjustable for just cutting the very tiniest wires. Check it out, boys. This is a 550 motor by Johnson Electric. Look at the quality. That's excellent. It looks really nice to me. I could put my pulleys right on that shaft and my little bearing on the end. No epoxy needed. A nice beefy, solid motor. Man. $6.23. What? It's so cheap. I'm buying 10 of these. I'm buying 15 of them. $100. Ouch. But I need a lot of motors. I mean, I need a freaking lot of motors. I have so many projects underway. I need to stockpile. I'm not messing around. I need to be well supplied. What, 15? These are called RS 550. The other one is RF 470. Interesting.
Is that all the setup instructions? For now, we're just going to do a little demo with Humanoid.
I need a motor encoder. Wake up. Motor encoder. Alright guys, I just bought a motor encoder. Let me show you what I bought. Okay. So, it came with the motor actually. Here's the motor, it comes with it. It's only $1.39, free shipping. this little metal disc spins, and each time it passes one of these notches, this little octocoupler or whatever picks up a different reading, so it detects a tooth has passed through. And with the resolution of this being about, I don't know, 4 degrees, one full turn would be divided by, I don't know, it looks like 60 times. So it's really pretty fine precision, considering one full turn of this would just reel my string. I don't know, a linear translation of a full turn might be 3 millimeters, and we've got 3 millimeters divided by 60, so we're talking like 0.01 millimeters. This would give me very fine precision, and it can count indefinitely. What I was going to have is a multi-wind potentiometer connected to a spool of thread, and as the spool unwinds, the potentiometer turns and the resistance changes, and it can measure distance that way. But this would be a lot more precise, and I'm not sure how many turns a multi-wind potentiometer would have given me. Specifically, I'm referring to using this for my CNC machine to measure the total distance traveled of the Y, Z, and X axes. No, not the Z axis, just the Y and the X I'm worried about. The Z is just the tool head. That can be using multi-wind potentiometer or something. But yeah, I just bought a couple of these, and that'll help a lot with my CNC machine to measure the distance traveled of the main axes. It's going to work great. The motor itself is not strong enough to turn my CNC machine axes, but it can be turned on when the big motor turns on, and it will just not really do a whole lot. It'll add a little bit of extra pulling force, but the main point of it will just be to measure the distance traveled. I didn't need one because I was going to use a multi-turn potentiometer, but then it hit me that this would be more accurate. That's why I came back after I thought about it some more. That would give me finer precision with my CNC machine, which is nice. It's only $2.78 to really improve the performance of a CNC machine hugely. I think that's a small price to pay, really. Plus I get a couple free motors in the bargain to add a little bit more power to it, I guess. Stop listening. A Hall effect sensor and a rotary encoder I think are similar technologies. It's a similar concept for sure. Except from what I've seen, a Hall effect sensor just tracks when a magnet gets close. You put that magnet on a wheel and it will just track a single rotation, whereas a rotary encoder somehow is able to detect each tooth of a spinning metal plate with teeth cut out, and you can actually get micro precision of the wheel turns. So it's really it's different in its use case, and it's really nice for measuring the distance traveled of a CNC machine. It's based on a pulley system like mine will be. I mean, even if it wasn't a pulley system, you could measure the distance traveled in the different axes of a CNC machine based upon an encoder like that as well. Even if it was a worm gear, you could translate the teeth to a distance. And this would be a way for you to measure distance without using a stepper motor where you're counting each step. So it's kind of like turning a DC motor into a stepper motor by being able to count the DC motor turns in a precision way. And that's how I'm going to be doing my CNC machine, with DC motors, not with stepper motors. Brushed DC motors specifically. I'm not copying. I've seen 550 motors used on several other DIY makers YouTube channels, but just seeing specifically that 550 motors are what are used in cordless drills, I didn't know that, and he specifically said it in the video, and he does a lot of research, so he knows his stuff. And that really just locked it in. I wanted cordless drill motors for my robot. I've said that way before watching his stuff. I'd already seen 550 motors used in various things like homemade bilge pumps. And I'd already researched them and nearly bought them, but just wasn't sure and just was holding off. And when I found out that that's the kind of motor standard used in cordless drills, that just completely set me at ease that that's exactly what I need. And so I went ahead and bought that. Yes, DeWalt drill motors are probably a little better made, but that's arguable. I don't know for sure. Probably a little better. But I'm okay with that because the motors that I bought are $7. Buying used DeWalt drills was like $28 each, and I was just stripping it down for the motors anyways, so that was a huge waste. These are way, way cheaper. I'd rather just have a bunch of cheap motors as long as they're okay. He's not my superior, Mailbox. If you were in front of me right now, I would smack you right in the face and make you take that statement back.
On top of the robot, the actual bending, and that's because this is a square, there's two of these rods here. If there were one, obviously it could bend. Because there's two, it's held in a square. It can't bend unless the